Hey class, this is 3A problem set, 12, 14, and 20 for the first part of this. So 3A problem set, numbers 12, 14, and 20. So let's take a look. The first one is balancing equations. It's A through F. I'm going to do A through C, and then you do D, E, and F. They must be finished for you to get credit for this problem set. I'm going to do that for a couple of places here because you've had more than one chance to practice your balancing equations. So let's take a look at balancing. We balance for this, I start off with lithium on the left-hand side and lithium on the left-hand side. There's only one of them, but notice that I have 3 on the right. That means that I need a 3 in front. Okay, so that means 3 lithiums on both sides, so that's balanced. But then take a look. Notice that I have 2 nitrogens on the left-hand side, but only 1 on the right-hand side, which means I need to put a 2 in front of the whole thing. Now that doubles the number of lithiums that I have here, so I need 6 now. 6 lithiums, and then plus 1 N2 yields 2 Li3N. And that's it. That's how you balance it. Moving on to the next one, lanthanum. Not a normal element that we use very much, but that doesn't matter here because we can still balance it. Notice I have a 2 on the left-hand side, so I put a 2 on the right-hand side. I have 3 oxygens, plus let's do that one last. All right, I'm going to do that last. What I might do, no, let's keep it just like it is. I was going to change H2O to HOH, but we don't need to do that. This is kind of a strange one. So here I have 2 times 3 gives me 6 oxygens, and 2 times 3 gives me 6 hydrogens. So first of all, I recognize that if I have 6 hydrogens on the right-hand side, then I need 6 on the left-hand side by putting a 3 in front of the H2O. That gives me 3 times 2 is 6 hydrogens, and 3 times 1, that will give me 3 oxygens, and then I already have 3 here, which means that if I get rid of this, I can go 3 here plus another 3 equals 6. So I actually have everything balanced. So that's 1, 3, 2. Okay. Finally, letter C. What do you do when you have NH4 and NO3, but neither of those polyatomic ions switch to the other side? There is no NH4 on the right-hand side, and there is no NO3 on the right-hand side. Then you have to break them down into N's and H's and O's. Notice that there are 2 N's in this compound, even though there's no subscript 2. So the N shows up here, and it shows up here. So I have 2 N's. Over here I have 2 N's, so that's good. Here I have 4 H's, that's what the 4 is for. So I need a 2 in front here to get the number of H's on both sides. The next part of this is 3 oxygens. Here I have 2 oxygens plus another 2 means 4 oxygens. Always, always an issue with the oxygen. So here's what I do. I start to double things because it always seems to work. I have 2 N's and 2 N's gives me 4 nitrogens, which I put a 2 in front there to get 4 nitrogens. Okay, 2 times 4 H's gives me 4 times 2 to get 8 H's. So okay, now we might be getting somewhere. 2 times 3 gives me 6 oxygens. Here I have 2 oxygens plus 4 times 1 is 4 oxygens, which gives me 6 oxygens. So this actually works. So my numbers are 2, 2, 1, and 4. Okay, go ahead and do D through E. I'm expecting those to be finished and done, even though I didn't go over them on the screencast. So you should do those on your own. And if you don't do them, you won't get full credit for the problem set. So number 14, I'm going to do A and B. You do C. Again, if you don't do it, you won't get the points. So convert these descriptions. When sulfur trioxide gas reacts with water, there's everything. These are my reactants. When sulfur trioxide gas. Now these are prefix. This is a prefix. Sulfur trioxide. The tri tells me it's a prefix. Plus reacts with water, H2O. Okay. Over here on the other side it says sulfuric acid. Now if you remember how to write down the rules, if it's sulfuric, that means that it's sulfate. Okay, ic is 8, 8-ic, ite-us. So that means that SO4 with a -2, and then because it's acid, it's H+. I have to crisscross that to get H2SO4. That's how I write the formula for an acid. I change the ic to ate, which means sulfate, and then sulfate we know is H2SO4 with a -2. And then I put the hydrogen in front of that because it says acid. So now I go back through and I check to see. I have 1S, 1S. 3 plus 1 is 4 oxygens. 4 oxygens. I have 2 hydrogens and 2 hydrogens, so that's balanced. SO3 plus H2O yields H2SO4. Boron sulfide. So boron 2, so B2S3 reacts violently with water. So we're still doing H2S or H2O to form boric acid. This is an easy one because it gives it to you here. H3BO3 and hydrogen sulfide gas. Hydrogen sulfide, if you don't see any prefixes, then you write the symbols and charges. Hydrogen's a +1, sulfide's a -2, so it's H2S. This looks like it should be an acid, but it's not because it's a gas. Acids are dissolved in water. So I could write down gases for this also. And in solution, that means AQ, and obviously water's a liquid, and SO3 is a gas, so you put a G there. Okay, so what is this? This is a solid. This is liquid water, and then this is aqueous, dissolved in water, and that's a gas. Okay, so let's go back through and balance the equation. So 2 borons, and I only have 1 on the right-hand side, so I need a 2 in front here. That gives me 2 times 3 is 6 hydrogens, right? So how do I get 6 here? I put a 3 in front. 3 times 2 is 6 hydrogens. That also gives me 3 oxygens here. How many sulfurs do I have here? Ooh, uh-oh. So that means that I need to first get rid of the 3 in front. Poop. There we go. And that comes down to, good. Now, I didn't see the number of, there we go. So I got 6 here. 2 times 3 is 6, so that gives me 12. That's 12 hydrogens. I had to put the 3 here to get the same number of sulfurs on both sides. Okay, so that gives me 6 plus 6 is 12, so I need a 6 here. That gives me 6 oxygens, and 2 times 3, I'm going to get rid of all of this business here so that this looks nice. There we go. 2 times 3 gives me 6 oxygens. So that actually balances now. So that's B2SO3 plus 6 H2O yields 2H3BO3 plus 3 H2S. That's it. Excellent. Last one. Remember, you're doing letter C. You're going to complete that. Go through the 3 steps. I want you to write the prefix. Remember the 3 steps. I do, the first one is symbols and charges, prefixes, and Brinkelhoff. Step number 2 is crisscross. Step number 3 is balance. Okay. All right. That's what I did for all 3 of them, for the 2 that I did. Next, number 20. Okay, so this is identifying the type of reaction. This is a combustion reaction right here. COMB, comb. And then we'll balance the equation in a minute. B, C, D, E. So let's see what we got here. This one is a decomposition. Definitely a decomposition because it's just one thing and then the arrow. And then here I have, I haven't talked about combustion yet. So combustion is when you have a carbon, X, hydrogen, Y, plus O2, and on the other side is always CO2 plus H2O. If you get something other than CO2 plus H2O as a product, then it's not a combustion reaction. So it's a combustion of carbon and hydrogen compound. So here I have also oxygen with it, but notice that my products are correct. So this is a combustion reaction. Okay, N2 plus H2. This is clearly a synthesis reaction because it's an element plus an element. We should know that. And then this one here is, this one doesn't follow This is actually also a synthesis reaction. Do you know how I know that? Notice that there's only one product for this synthesis reaction, and there's only one product for this synthesis reaction. Okay, let me see if there's any more. Sometimes there's more. So, nope, that's it. So let's balance some equations. I'll do the first three. You can do the last two. So I'm going to get rid of this stuff here. So three carbons. If I put a 3 in front of here and a 3 in front of here, now I have the number of carbons and the number of hydrogens balanced. So oxygen is the only problem. 3 times 2 is 6, and 3 times 1 is 3, which means 9 oxygens. How do I get 9 oxygens when I'm multiplying by 2? Well, I don't. So I double everything. You guys hear me say that all the time. I'm just doubling stuff because it works. So 2 times 3 is 6, and 2 times 6 is 12. So 6 times 2 is 12. There we go. Now we get 6 times 2 is 12 oxygens here, plus another 6 is 18. So there's my 9. So 2, 9, 6, 6. Good. So here's my decomposition reaction. I get 2 N's, 2 N's, so that balances. I got 4 H's, so I put a 2 in front here to get 4 H's. I got 3 oxygens. I got 1 plus, and then because of that 2, another 2 oxygens is 3. So just a 1, 1, 2. Super easy. Let's keep going. I got 5 C's here, so a 5 in front of there. I got 6 H's there, so a 3 in front of there to get 6 H's. I have 1 oxygen here, so let's see what we got. 5 times 2 is 10 oxygens, and 3 plus 3 is 13, like this. Now look what we got over here. We got a stray oxygen, so 1 plus whatever this is going to have to equal 13. If I put a 6 in front, 6 times 2 is 12, and that equals 6. That equals 13. So 1, 6, 5, 3. Okay, you can balance the other two at the end. These two here, make sure that you balance those since I identified them, and you won't get total points if you don't do that. So thank you for paying attention. Stay tuned for part B.